Hello everyone and welcome to your Law of Sines, Law of Cosines review part 1. In this video we're going to be going over problems 1 through 6. There will be 3 parts to this review as there are 16 problems. I'll be going over different problems in each section. Feel free to check into whatever videos you need. I have also posted an answer key on Canvas, but if you want to hear me go through the stuff, this is where I'm gonna be. So let's get started with problem number 1. So problem number 1 actually already gives us the triangle, which is very nice. If you can, always draw the triangle. That's gonna make life so much easier. And it's also easier for me while I am grading, because then it kind of gives me a really nice spot just to go through and see, hey, where are all your answers? So in this one, side length A was 22, side length B was 20, and our angle C is 95 degrees. So if you take a look at the instructions in the review, it asks for 3 things. First thing it wants you to do is to state or identify whether you're going to be using law of sines or law of cosines. So I take a look here, I see this is an example of side, angle, side, because the angle's in between the 2 sides. So this is going to be law of cosines. That's what I will be using. The next question is, please state the number of solutions and show your work. That's if applicable. So for instance, here, that may not be applicable because all law of cosines problems just have one solution. You will need to show your work if you end up in any ambiguous case for law of sines. So here we are. So now that we know it's law of cosines and it's a 1 solution, next step, if it is a 1 solution, solve for the rest of the triangle. So I'm going to find my last 2 angles as well as my last side. For my side lengths, please round to the 2nd decimal place. Angles, please round to the 1st decimal place. Although I'll let you know for this example, everything turns out pretty nice. But let's get started. So let's see. First step, I'm going to solve for side length C because that's my last side length and I already have my angle C. So I'm going to be using C squared is equal to 22 squared plus 20 squared minus 2 times 22 times 20 times cosine of 95. Let's see what I can do. So this will be C squared is equal to 44 plus 400 minus 880 cosine of 95. Let's add up these numbers. So we got 884 minus 880 times cosine of 95. Now remember, I cannot do 884 minus 880 because that 880 is being multiplied to cosine of 95, and multiplication takes precedence over that subtraction. So the only thing I can do now is to get C by itself, and in order to do that, I must square root both sides. So I get that C is equal to the square root of all of the shenanigans. Now notice I haven't gone through and simplified anything yet or rounded early. I've left some comments in homeworks recently about making sure you're not rounding too early. But anyway, we get to here, and when we plug this into the calculator, we get C is 31, which is kind of nice. So you see that C is 31. You can see that I'm putting this into my side lengths, or back into my triangle. And now that I look at this, I go, okay, I can do law of cosines again. However, law of sines is kind of faster, so that's what I'm going to do. I'm going to solve for my angle A and set up my law of sines. So I'll use sine of 95 over 31, my pair of C, since that's what I know, is equal to sine of A over 22. From here, I will cross multiply. 31 times sine of A is equal to 22 times sine of 95. I divide both sides by 31. That's a 3, whoop, there we go. And then to get A by itself, I must use sine inverse on both sides. So I'll have A is equal to sine inverse of 22 sine of 95 over 31. And when I plug this into my calculator, I end up with 45 degrees, which is nice. So remember, when we're dealing with law of cosine, our 3 steps are always going to be use your law of cosine, which I've done in green, use your law of sine, which I've done in blue, and then the last one is to use your triangle sum theorem, which says that all the angles of a triangle must add up to 180. So we can say that angle B is going to be, if we just take 180 and subtract our other 2 angles, and we're going to end up with 40 degrees. And that is our last step for this problem. So this is what a problem is going to look like for law of cosines. Our next one, however, is going to be just a little bit more interesting. So let's move there. Let's see, oops, move some things around. Problem number 2. Problem number 2 tells that side length B was 40, side length A was 32, and angle A was 125 degrees. Now I knew that the first 2 were side lengths because those were both lowercase, and my angle, which has a degree sign, is uppercase. So make sure that you're looking out for that. Now when I draw this triangle, some of these you'll notice I'm trying to draw to scale, some of them I'm not. I'm just kind of showing you different situations that you might see. So let's see, if we call this A, B, C, so we know that A is 32, that B is 40, that A is 125 degrees. Okay, first thing I look at, I notice that this is an example of side-side angle, which means I will be using my law of sines. Now, side-side angle is my ambiguous case. So here's where I'm going to have to check to see how many solutions are there. Well, I take a look at this and I see, well, my angle that I'm given, my angle A, that's greater than 90 degrees. So I'm going to look there first. That can be found in our first law of sines video. But I notice that this angle here is across from 32, but side B, 40, is actually larger, which is a problem because the largest side must be across from the largest angle. So I notice that our angle A is greater than 90, whoops, but the largest side is not across from the largest angle. So since that's not happening, this can't possibly be a triangle. So this is an example of a no solution for when the angle is greater than 90. And this is what I mean by showing your work. If this was a problem on a test and you didn't show anything, you just said no solution, I'm going to be like, how do you know that? Why is that true? Something of that nature. So this is kind of what I'm looking for here. Just maybe a quick sentence about it's a no solution and how do you know that? So like I said, that one's a little bit more interesting. Let's take a look at problem number 3. Problem number 3, we know that angle A is 70 degrees. Side length C is 26. Side length A is 25. So if I was to draw this, this one's not going to be to scale. A, B, C. You'll also notice that I will go through and change the placements of my A's, my B's, my C's, just kind of for whatever suits my need. So you don't always have to keep it in the same spots. Let's see, I know that side length C is 26, side length A is 25, and angle A is 70 degrees. So I look at this, this is another example of side-side angle. So I know I will be using the law of sines, but in this case, our angle is less than 90 degrees. So I'm no longer just looking at those side lengths, I now have to compare everything to my height as well. So I need to find my height, and just a reminder, your height is going to be your adjacent side times sine of your angle. So usually we say b sine of a, but in this case, I'm not dealing with side length b, I'm dealing with side length c, which is why I'm just saying adjacent side. So for us, that specifically is going to be h is equal to 26 times sine of 70. And when I plug that into my calculator, that's going to give me 24.4. Okay, so now I'm going to compare this to my opposite side of my angle, or that side length A. So I can say, okay, 25, that is in fact greater than 24.4, or my opposite side is greater than my height. So I'll write that in there. So since my opposite side is greater than my height, I know this is going to at least make a triangle. So this is going to be at least a one solution. Now I have to take my opposite side and compare that to my adjacent side. So we can see here that 25, that's going to be less than 26, or that side length A is less than that side length C, which means that kind of when I move that side length A around, it's going to be trapped within the triangle, making another solution. So when we have our opposite side is less than our adjacent side, but our opposite side is also greater than our height, this is going to be an example of a problem with two solutions. Now again, you may leave it here. You have identified the number of solutions. The third part of the instruction said, if it's a one solution, please continue. This is not a one solution. You do not need to continue with this. So let's continue with the review instead. Let's take a look at problem number 4. Problem number 4 tells us that side length A is 84, angle C is 58 degrees, and angle B is 70 degrees. So if I was to draw this triangle, I'm not going to draw this to scale, I'm just going to kind of put it out here like this. A, B, C. Let's see, we know that angle C is, 58 degrees, side length A is 84, and angle B is 70 degrees. So this is an example of angle, side, angle, which tells me that, again, we're going to be using the law of sines. And now, this is not the ambiguous case. It is still law of sines, but it's not a side-side angle. And because of that, if you're dealing with angle, side, angle, or angle, angle, side, it's just a one solution. You don't have to show the work for that. You can just state that that is a one solution. That is perfectly fine. But from here, now that it is a one solution, let us solve for the rest of the triangle. First thing that I see is that, hey, I already know two of my angles. So in order to find angle A, I can do 180 minus 70 minus 58, and it'll give me that angle A is 52 degrees. First part done. Awesome. Let's keep going. Next, we need to find our side length. So to do that, I'm going to set up the information that I know, the pair that I know. Sine of 52 over 84 is equal to, and then I can choose side length B or C. I just usually go with the largest side, or the one that's across from the largest angle. So let's go for B first. So we'll do sine of 70 over B. From here, we will cross multiply and get B times sine of 52 is equal to 84 times sine of 70. Now we need to divide both sides by sine of 52. You may notice I'm not including those kind of in-between steps. You can if you want, but what I'm showing you is the minimum amount of work that I want to see. So from here, when we divide both sides, we get 84 times sine of 70 over sine of 52. And when we plug that into a calculator, we get that B is 100.17. Remember, please round to the second decimal place for your sides. So I'm going to include that, there we go, in my triangle. And then last but not least, we must solve for our last side. So I'm going to set it up very, very similarly. Sine of 52 over 84, so a pair of things that I already know, is equal to sine of 58 over C. I'm going to do the exact same steps that I did in the green. So first I will cross multiply. C times sine of 52 is equal to 84 times sine of 58. Ooh, almost ran out of space. Divide both sides by sine of 52. So C is equal to 84 times sine of 58 over sine of 52. And we are left with 90.4. That's what it would end up being to the second decimal place. I just 0.40. We get 90.4. So this is an example of a one solution for a law of sine. We have 2 more problems left in this video. Let's keep on going. For problem number 5, we are given another triangle that is already drawn for us. How nice, how convenient. Looks something like this. We got A, C, B, B, A, C. Let's see, we know all of our side lengths this time. We know that B is 17, we know that C is 11, and we know that A is 10. So this is an example of side, 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 meaning we will be using our law of cosines. And again, law of cosines, no matter what, there's only ever one solution. So I don't need to show any work for that. Now, when we're dealing with law of cosines, it's very, very important to solve for the largest angle first, or else you get into this really sticky situation of having like a 2 solution with a law of cosines, and it's messy. Just so we're getting around that by just saying solve for the largest angle first, and then the next largest angle, and continuing this way. Which means we're going to solve for angle B first, since it is across from the largest side. Which means I'm going to have to use the variation of law of cosines that has angle B in it. So that's going to look like 17 squared, so B squared, is equal to 11 squared plus 10 squared minus 2 times 11 times 10 times cosine of B. So I'm solving for that very first angle. Now let's see what we can do. We get 289 is equal to 121 plus 100 minus 220 times cosine of B. Let's add those first 2 numbers together. 289 is equal to 221 minus 220 times cosine of B. Remember, I cannot do 221 minus 220 because of order of operations. So instead, I'm going to subtract 221 on both sides and get 68 is equal to negative 220 cosine of B. And then to get B by itself, I'm going to divide both sides by negative 220. And then to officially get B by itself, I'm going to use cosine inverse on both sides. So we get cosine inverse of negative 68 over 220 is equal to B. Again, notice I haven't plugged anything into my calculator. I haven't simplified anything yet. But when I do this, I get 108 degrees. So that's step 1 for law of cosines. Step 2 is to use our law of sines, and again, I'm going to solve for my next largest angle, which will be C. So for my law of cosines, I'm going to say sine of 108 over 17 is equal to sine of C over 11, and solve from here. So we'll have 17 times sine of C is equal to 11 times sine of 108, divide both sides by 17. And then use sine inverse to officially get C by itself. So you have C is equal to sine inverse of all of the above shenanigans. And when I plug that into my calculator, I get 38 degrees. And then our last step for law of cosines is to use our triangle sum theorem. So we'll say that angle A is 180 minus 108 minus 38. We get angle A is 34 degrees. So this is a law of cosines problem. We've got one more problem left in this part of the video. Let's keep on going. So problem number 6, oh, I'm looking at the review. I gotta move my thing. There we go. Tells us that angle B is 73 degrees. Side length A is 7. And side length B is 5. So if I was to draw this out, let's see, we said B was 73 degrees, A was 7, and B was 5. So I take a look at this. This is an example of side-side angle, meaning you will use your law of sines. Now, since this is side-side angle, that means this is going to be an ambiguous case, so I do not know the number of solutions. I look at my angle, and I notice that this is less than 90 degrees. So since it is less than 90 degrees, I need to go through and check out my height and see what's going on there. So again, just a reminder, your height is your adjacent side times sine of your angle. So for us, h is going to be 7 times sine of 73. That's going to be 6.69. So when I compare this with my opposite side, we're going to I just noticed that I muted myself for a little bit. Whoops, sorry. Hopefully you've been able to follow along. But basically I'm saying the opposite side is shorter than the height, which means it doesn't even make a triangle. So I am sorry if there was some miscommunication there at the end. That is my bad. Please feel free to email me or drop into a Zoom meeting if you have any questions about this. If you don't, please head to the next video.